Hey all, welcome back. In the previous session, we have talked about what is blocking statement and what are non-blocking statements, right? And we have also seen the difference between blocking statements and non-blocking statements. Is it or not? So, if you are new to my channel, consider subscribing my channel and hit on the notification bell also. And also, I'll be providing the links of both blocking statements and non-blocking statements videos in the description box. You can go check it out there. Also, so in today's topic, we are going to see the difference between blocking and non-blocking statements. Like how in the previous chapter, in the previous sessions, we have discussed how the execution takes place in blocking statements and non-blocking statements. But in today's class, what we are going to do is we are going to see the difference, like how the difference. In the previous class, we have seen that toggling is taking place and the execution is being done. So, how are this being executed? So, what is the exact difference? What is the thing that is going inside the execution of the blocking as well as non-blocking statements? In today's class, we are going to see that. Okay. So this is the example. So let us see by analyzing this particular example, we'll see. I'll show you the difference between blocking statements and non-blocking statements. Right? Okay, module blocking, non-blocking in clock out. So I have taken like two inputs like input and clock and one output OUT. Okay, in this input is this and output is OUT. And here I am again taking three registers like Q1, Q2 and out. Okay, now if you see, always at the rate of passage of clock, begin and end. Within begin and end, I am taking like three values. Like if you see here, Q1 equal to input, okay, and then Q2 equal to Q1 and then out equal to Q2. Okay, so for the same thing, for the same, if you see this two examples here, all the everything is same within these two examples, only that I'm just using non-blocking as well as blocking. Now let us see how this thing will be happening, how the execution will be happening, or how will be the, what is the difference that you are going to see here. Okay, for example, if I am taking the value of input, okay, like input equal to, for example, 0 and q1 equal to 1, q2 equal to 1. Okay, these are the two values, 1 1 and input is 0. Now if you see here, in the case of non blocking assignment, what is happening? First the initialization is being done. So input is 0, q1 is 1, q2 is 1. Okay, so after this, the values will be q1 equal to 0, q2 equal to 1, okay, and out equal to 1. So this is what you have given, is it or not? So that is what it is happening here. Okay, q2 equal to 1 and output equal to 1. This is the series that you have taken, and this is the series that you are getting for your output. Fine. Now let us see the same thing for blocking assignment. If you see for the blocking assignment, same thing like input is 0, q1, q2 are 1 1. So if you see here, this will be executed sequentially. So the input value is assigned to 0 as 0 and it is given to q1. So what is the q1 value now? 0. And then after assigning it to LHS, then comes the second statement. Now what is the q1 value? Q1 value is not 1, it is 0. Okay, so what is the q1 value? 0. So after q1 value is assigned as 0, then it is given to q2. Then now what is the q2 value? 0. It is not 1 as you are taking. Okay, now if you see, this q2 value is given to output. So what is the output value? Obviously 0. So what is the input that you are giving? 0 1 1, but what is the output that you are getting? 1 0 0. Is it correct? No. So finally, what is the thing that you are getting for output? Output is nothing but, if you see, what is the input that you are taking as, if you see, input is 0, so output is 0. Obviously the two registers that you are taking are have become useless in case of blocking assignments, because they are not passing any value. They are since it is executing sequentially, it is erasing all the values that you are given and it is just putting the input value to output. So here if you see, I have written something. when non-blocking assignments are synthesized, the output will be actually in the form of serial input, serial output. Okay, like what is the input that you are taking serially, the same output you can expect. But in case of no blocking assignments, what is happening means you don't have any serial input, serial output. What is the value of Q2? Q2 output is nothing but what is the input that you are taking, that is the output that you can expect. There is no serial input, serial output in case of blocking assignment. Why is this happening? See, what is the internal working of this blocking and non-blocking statements? So if you see, this is the thing that I have given, is it or not? This is the logic that I have given. So the same logic. Now what will be happening means when you are internally designing it like that, when the designing is done, that the working is happening in this way. Like input, when you are designing a non-blocking assignment, okay, for every assignment, like we can say that a flip-flop will be designed. Okay, here, since you are having three assignments, three flip flops are designed. But in case of non blocking assignment, what is happening here? Only the single flip flop. Like, that is why whatever input that you are taking, that is the output you are getting. The Q1, Q2 doesn't have any, since they doesn't weigh any value in case of your blocking assignments. Okay, see at each raising clockage, Q1 is input. After that, Q2, Q1 are obviously input. After that, output equal to Q2 equal to. Finally, what is the output? Output is nothing but the input, because these are not holding any value in case of your blocking assignments. Whereas in case of non-blocking assignments, what is happening, since everything is done parallelly, so at every raise of clockage, Q1, Q2, Q2 simultaneously receive the previous values. Look, what is the values that they are holding previously? They will be receiving it, and that is why they are able to assign it at the final stage, so that you are getting all the values that you are giving at the input. Got my point? So basically, this is the thing that is happening in case of blocking and non-blocking assignments. So this is how. Since you are taking three assignments, three flip-flops are generated. Whereas in blocking, if you are taking five statements, then five flip-flops are generated. But how many statements you take in blocking? You will just get what is the input, that will be your output. That's it. The intermediate connections doesn't hold any weightage in case of blocking assignments. Got my point? So this is the major difference between blocking and non-blocking assignments. So hope you got the difference between blocking and non-blocking statement. So this is the small tabular form that I have prepared for you in order to see the difference between blocking statements and non-blocking statements. So in the blocking statement, as you already know, the evaluation of the expression of RHS is updated, and the LHS is autonomously based on the delay value. Okay, if there is delay, based on the delay it will be updated. If there is no delay, there will be, then it will be automatically updated without any delay. But in case of non-blocking statement, the occurrence, like the operation is being done, but the assignment will take time. Okay, it won't be updated immediately, but when it will be updated, I think you know that particular thing. Okay, so this is the one difference. And when multiple blocking statements are present in the process, the trailing assignments are blocked from occurring. Okay, that means when there are multiple statements in the assignment block, every statement will be executed in a form of sequential order. But in case of non-blocking assignments, all the statements will be executed parallelly. So because of this execution of in a sequential order, and because of blocking the remaining statements until the execution of first statement, because of this sometimes there is a condition called race around condition that occurs in the blocking statement. We'll see about the race around condition in the next log. Okay, so this is presently the disadvantage in case of blocking assignment. In case of non-blocking assignment, since all the executions are done parallelly, and also the RHS update is not done, the LHS update is not done immediately. So because of this, the race around condition is not occurred in case of non-blocking statements. So basically, when it comes to blocking and non-blocking statements, okay, mostly what is the, okay, this is not like we should use it in this manner only, but blocking statements we will be using in combinational circuits. Like in order to design the combinational circuit, we will be using the blocking statement. And in order to design like sequential circuits like flip-flops and all, in order to design those kind of circuits, we will be using the non-blocking statements. Okay, this is not mandatory that we should use it in this manner only, but mostly while we are designing the circuit, we will be using blocking statements for combinational circuits and non-blocking statements for sequential circuits. Okay, and both blocking statements and non-blocking statements, we can use initial always blocks in both blocking statements as well as non-blocking statements also. Okay, so this is what the difference between blocking and non-blocking statements. In the next class we will be discussing about the delay in behavioral modeling, how we are going to give the delay and how the delay is going to affect the blocking statement as well as non-blocking statements, and also we'll be discussing about the race around condition. Okay, so that is all for today. If you like my explanation, please consider subscribing my channel and hit on the notification bell also. Also follow me on LinkedIn where I'll be uploading the videos of this particular sessions. Okay, please share this to all the VLSI aspirants who are also enthusiastic in learning VLSI front end courses like Verilog, System Verilog, and UVM. Right? So that is all for today. Thank you.